Hello, Math 3 and Math 3 Plus. Today we're on lesson 1.1b, and we're going to be talking about normal distributions and determining whether or not a set of data is a normal distribution. So let's go ahead and jump into today's lesson. We're going to start off, we kind of ended off with this last time with our histograms that we'd made, and we talked about how we noticed that on ePhones and on unlimited phones that they both had a peak near the middle, right near that mean of 10 hours, and we noticed that ePhone was a little more spread out and unlimited was a little tighter and a little taller in the middle. So it seemed to us that ePhone was a little less consistent with their battery life, whereas Unlimited was a little more consistent, and that both of those histograms appeared to be pretty symmetric. Kind of started low, came up in the middle, went down low on the other end. We call this a normal distribution. A normal curve is a bell-shaped curve that is symmetric about the mean of the data. If the mean is the average, it makes sense that the bulk of your information is going to be clustered around that mean. And so we call this a normal curve. And a normal curve models a theoretical data set that is said to have a normal distribution, that most of your stuff is going to be clustered around your mean or average in the middle, with a little bit more than and a little bit less than, but most of it's going to be hovering around your mean. And of course, we saw the means for ePhone and Unlimited. If we were to do rough little curves for that, they would look kind of like these guys here. Now, you might be able to notice here that ePhone is a little bit wider and a little shorter than Unlimited, which we noticed when we did our histograms, that Unlimited was a little tighter around the mean, a little narrower, and a little taller. And we'll come back to that idea in just a few moments. Now, although normal curves, they can be narrow, they can be wide, all normal curves are symmetrical about the mean of the data. So all of these are normal curves. You can see that if I were to fold it right down the middle, that curve would fold right on top of itself. Starts low, comes up high in the mean, and drops back down again. And this one's shorter, but it's doing the same thing. This one's kind of more like in the middle, but again, comes low, comes up high, drops back down again. These are not normal distributions. You can see that around the middle it dropped down instead of coming back up. So it's definitely not a normal distribution. This one's not symmetrical. You can see it's clustered a little on the lower end. This one's clustered a little on the higher end. So neither of these are normal distributions either. In order to be a normal distribution, it needs to cluster around the mean, and it needs to be symmetrical. Just some information that you're going to want to know. You probably don't need it, but if you see these symbols, I don't want you freaking out. The mean of a population is represented with the symbol mu, and the mean of a sample is represented with the symbol x with the line over it. As data spreads out from the mean, we call those standard deviations. It's the standard deviation, and it tells us just how spread out the data are from the mean. And it's super easy to find standard deviation. I'll show you how easy this is. So for example, for ePhone, you can see that the mean, let me get a little pen here, and we can see that my mean, sorry for the bad mouse handwriting, is 10, right? That's where we hit our peak. But my standard deviation, so how I get from one notch to the next, is just the difference from 10.0 to 10.5. So my standard deviation ends up being, well, 10 to 10.5 is just 0.5. For Unlimited, you can see again that my mean is also 10, but notice how Unlimited is a little narrower. It's a little taller and a little narrower. It's a little more squished together. And that affects, we can see that within the standard deviation. Notice on Unlimited, I go from 10.0 to 10.4. So that means my standard deviation is only 0.4. So this is kind of interesting to notice that as I get a little wider and a little more spread out, as my normal curve is a wider, I have a larger standard deviation. But when my normal curve is a little bit more narrow, I end up with a smaller standard deviation. That's interesting to notice here. Now, the symbol for standard deviation of a population is sigma, so sometimes you'll see the sigma symbol used, and the symbol for standard deviation of a sample is just an S. So be aware if you see either of these, we're just talking about standard deviation. And as we were just noticing, a lower standard deviation represents data that's more tightly clustered around the mean. So a lower standard deviation is going to be a skinnier normal curve, whereas a higher standard deviation represents data that's more spread out from the mean. So a higher standard deviation is going to give us a wider normal curve. So we won't go into all the details here, but if I were looking at these three normal curves, and I was told that one of them had a standard deviation of 0.1, another one had 0.4, and another had 0.5, could we match these up? Well, I'm looking at A, which is the tallest one out of all of them and definitely the least spread out. It's pretty clustered around the middle here. So to me, that says that A is going to have the lowest standard deviation. So I would put 0.1 with A. It would have the lowest standard deviation. B is a little bit taller than C, so a little more clustered around the center there. So I would give B a standard deviation of 0.4, and that means I would give C a standard deviation of 0.5. It's kind of the shortest, the whitest, that happens. That's a thing. Now, what if they have the same standard deviations, but I start messing with the mean of my curves? Take a look. You can see that A peaks a lot lower than B, which peaks lower than C. So while these curves are the same width, so they have the same standard deviation, these curves have been shifted left and right. So a lower mean means that your curve is going to shift to the left, and a higher mean says that your curve is going to shift to the right. So A is going to have the smallest mean and C is going to have the greatest mean, but their standard deviations are the same. So if the shape of the curve doesn't change, but we go left or right, then that means that our mean has changed. So I hope this was helpful to you. Again, as always, email me if you got questions or concerns. Come talk to me, come see me. That's what I'm hanging around this place for. And of course, I'm around before school and after school, particularly Tuesdays and Thursdays after school. Come talk to me. I can help you out. And I'll see you soon. Bye.